Hi there everyone, welcome to Saurav's classes. My name is Ashmita. Today, as you all can see over here, we are going to solve a portion or a set of questions from the geology paper of IIT JAM 2023. I have been selecting 5 questions for each class. Today we are going to solve from question 11 to question 15. We are going to do a little bit of explanations also on the options which are not correct as well as on the option that is correct for you all. Here is the phone number on which you can contact for more details, classes, inquiry, and information, or if you want to give mock tests. Do contact us and enroll yourself so that we can help you prepare well for the exams that you are aspiring for. Let's start with a question that is given, that is question 11. Which one of the following is gently sloping volcanic landform which is resulting from eruption of basaltic lava? Okay, your answer would be shield volcano. No composite volcano, no lava dome, no caldera. Now, shield volcanoes is the correct option because shield volcanoes are formed by the eruption of the fluid basaltic lava. Okay, and this basaltic lava flows easily and travels far from the volcanic vent. Like if suppose here is the volcano, if all the lava comes out in this place, it can travel far off. Okay, far off from the vent, and it can easily spread. It does not stay intact in one place after coming out. Now, this entire thing results in a broad, gently sloping mountain with shield-like shape. Okay, with a shield-like shape, this comes out and then forms a shield-like shaped mountain. Um, Hence, we can name this thing which is coming out, the lava that is coming out and then forming a volcano, as the shield volcano. That is given in the option. Examples of shield volcanoes can be Mauna Loa. Mauna Loa. Where is this? This is in Hawaii. Another example can be Mount Etna. Mount Etna, this is in Italy. It's quite a famous shield volcano. Mount Etna in Italy. All right. So yeah, we have discussed about the shield volcano. Now the other options, why aren't they correct? Let's start with a composite volcano. The composite volcano is actually a stratovolcano. Okay, and these are having steep sides. Now there is a difference between lofty and steep. Steep means absolutely steep, straight, and lofty means there is a curve. Like it's not that much steep. So here lies the difference. So stratovolcanoes or composite volcanoes are steep-sided mountains which are formed by the eruption of viscous lava and ash. So lava domes, on the other hand, okay, that was all about the composite volcano, that it is formed by the eruption of volcanic lava and ash. Now moving over to lava dome. Lava domes are small bulbous volcanic moles which are formed from the slow extrusion of the highly viscous lava. Okay. And calderas, on the other hand, the last option that is left with us, calderas are large dome-shaped depressions. Okay, depressions means there is a depression, like it is not in the form of a mountain, it is in the form of a depression. So these are depressions that form after a volcanic eruption when the magma chamber below the volcano is emptied and the volcano collapses in on itself. Okay, this happens, this is the totally different thing, that is caldera. Here the entire volcano erupts and collapses, then a caldera formation happens. So caldera is totally different from the other ones, and we have already discussed what the other volcano means. Okay. Now let's move over to the next question. That's question number 12. On the magnetic polarity, on the magnetic polarity time scale, the present day epoch or tron is called dash. Let's get to see the options. It's written Matsuyama, Gilbert, Gauss, and Roots. Here it would be Gilbert. Okay, your correct answer is Gilbert. Gilbert Cron. That's your answer. Now, the magnetic polarity time scale that is mentioned in the question, the magnetic polarity time scale, this is actually a timeline of the Earth's magnetic field reversals rather. Okay. Now, if we go back to history, we will see that these magnetic field reversals have had happened in history or have had happened throughout the history of the formation of the Earth. And these reversals are recorded in the rocks on the ocean floor, where the Earth's magnetic field has left a record of its polarity in the form of magnetic stripes. Here we can say the time scale is divided into several epochs or crons. Epochs or crons, it's already mentioned. It's divided into epochs or crons, and each has been named after a notable reversal event. Like the present epoch or the present chron, which began approximately 0.78 million years ago, and it still continues to the present day. It's named after William Gilbert. Okay, William Gilbert. Who was William Gilbert? Gilbert was a 16th century English scientist who first proposed this idea that the earth behaves like a giant magnet. Now, you all have seen a magnet or any kind of magnet I'm talking about, not only this kind of magnet, but any kind of magnet. Um, it, like our earth is a huge magnet and it acts like a magnet. Okay. All right. So our answer was Gilbert Cron. Let's move over to question number 13. Which one of the following options is the correct sequence of seismic waves in order of arrival time recorded on a seismogram after an earthquake? Now here, just go through the sequence that is given in option A. Then let's go through the options in B. No, these are not the correct orders. Yeah, moving over to D. Yes, D is your correct answer. Okay, D, option D is your correct answer. P waves, S waves, love waves, and Rayleigh waves. So, P waves, what are P waves? P waves are primary waves. Okay, and these are the fastest seismic waves, and they travel through solid also, and they travel through liquid rocks also. What about S waves? S means secondary waves. Okay, secondary waves or S waves are kind of slower than the P waves. Okay, and they can travel like this. S waves can travel through solid rocks only, and primary waves can travel through solid rocks as well as liquid rocks. Okay, that's the major difference. Now talking about the surface waves. Okay, surface waves are uh, kind of the other name that we can provide to Rayleigh waves and love waves. Both can be considered under surface waves. So I'm writing surface waves over here for love waves also as well as for Rayleigh waves also. So surface waves, which includes both the Rayleigh waves as well as the love waves, they are the slowest seismic waves when we are comparing them to the primary waves and the secondary waves. Okay, and they travel along the surface of the earth. Like these surface waves travel along the surface of the earth. These waves cause the most damage during the earthquake because they travel along the surface. That is why these waves, that is the Rayleigh waves and the love waves, these waves cause the most damage during an earthquake. Anyway, our correct sequence was this option D, in the sequence of seismic waves in order of arrival time recorded on a seismogram after an earthquake. Okay. That's the correct option. Let's move over to the next question. That's question 14. It's a match the following thing. You have to see it properly. Don't get confused. Match the geomorphic agents in column 1 with their corresponding landforms in column 2. Column 1, column 2. Okay, this is a little bit confusing. Actually, the way it is presented over here, it's a little bit confusing, but in the question paper, it was presented properly. Anyway, so it's given P2, right? Yes. With wind, Yardang will go, groundwater, yeah, Doline will go, with glacier. Yes, we can clearly see this is there in option A. Okay. So yeah, go with option A. A little bit about the Yardang. It's Yardang is a streamlined, wind sculpted bridge. Okay, it's a wind sculpted bridge that is found in arid regions. All right. So Yardang is a streamlined, wind sculpted ridge that is found in arid regions, means dry regions. And Doline, the next option, Doline is a depression in the ground. Doline is a depression in the ground which is caused by the dissolution of limestone by groundwater. And the last one, drumline. Drumline is, sorry, not drumline, it's drumlin. Drumlin is actually a very smooth, we can say, elongated hill. Okay, that is formed by the movement of a glacier. It's kind of a smooth, elongated hill that is formed by the movement of a glacier. And a back swamp is a low-lying area on a this is a back swamp is mostly found on a food plain which is behind a natural levee formed by a river. Okay, so yeah, that was the discussion regarding the four geomorphic agents, okay, and their landforms. Our correct sequence was option A that I have already told. Let's come to the last question for today's class. Which one of the following processes is not a mechanism for bedload sediment transport in a river channel? We have cavitation, sliding, rolling, siltation. Now, just as you all can see, it's written not a mechanism, right? So, not would be cavitation. Okay. Cavitation is our correct answer because cavitation is not a mechanism for bedload sediment transport in a river channel. Therefore, option A would be correct. Now, bedload sediment transport, the term that has been used over here, bedload sediment transport, it's a river channel. And it can occur through several mechanisms. Like river channels can occur through several mechanisms, including sliding, rolling, saltation. Through different processes, this can happen. And sliding occurs when sediment grains move along the bed of the channel without becoming airborne. The rolling occurs, the option rolling I'm discussing, rolling occurs when sediment grains are lifted and they are rolled along the bed by the current. Okay. And talking about saltation, the last option, saltation occurs when sediment grains are again lifted, just like in rolling what happens, and then they are bounced along the bed in a series of short jumps. They are bounced along the beds. Okay. All right, now talking about cavitation in details. Cavitation is the formation and collapse of vapor bubbles, okay, vapor bubbles in a liquid due to the pressure fluctuations. In a river channel, what happens? Cavitation can occur around rocks, then on other obstructions in the channel, which can lead to the erosion of the bedrocks. However, talking about cavitation once again, it is not a mechanism for bed load sediment transport in the channel. Okay, so that is why this is your correct answer. Now, I have already given the contact number for having more detailed discussion in our live classes. You can get access to the recorded lectures also, doubt clearing sessions, and mock tests if you want to practice with us. And if you want to prepare with us with our guidance and supervision, then you can join our classes. And thank you for watching. Do meet me in the next class.